Hello everyone, my name is RLEANE and LEDESMA and I will be your tutor for today. So, our topic for today's video is the measures of dispersion. Before we proceed to tackling about it, let us first define what is measures of dispersion. Measure of dispersion is a measure of variability of a set of data that is a number that conveys the idea of spread for the data set. Now that we know the meaning of this, let's dive deeper into this and know what are the statistical values, which are the range, standard deviation, and variation. But I can remember there are two types of this, which is the ungrouped and grouped data. But for today's topic, I will only be doing the ungrouped version. So, I do have some samples to further understand this topic. You can see it says, find the range, standard deviation, and the variance for the given samples. First of all, we have 1, 2, 5, 7, 8, 19, and 22. First step is to get the mean. So, how do we get the mean? The first step is to add these. Get the total and divide to how many numbers in the sample is. So basically, 1 plus 2 plus 5 plus 7 plus 9 plus 19 plus 22, which is now equal to 64. And since our total is 64, let us divide this to 7, because if we count our samples, we have 7. So 64 divided by 7 is equal to 9.14. This will be our mean. 9.14 is what we will use to subtract with the samples. So 1 minus 14 is equal to negative 8.14, and so on. So basically, we have 2 minus 9.14, which is negative 7.14. 5 minus 9.14, which is negative 4.14. 7 minus 9.14, which is negative 2.14. 8 minus 9.14, which is negative 1.14. 19, which is minus 2. 9.14 is equal to 9.86. While our last one is 22 minus 9.14, which is equal to 16.86. So, for our second step is to get the squared. Let's have our first one, which is negative 8.14. Negative 8.14 squared is equal to 66.2596. And now, you may wonder why if we try to get the squared, the answers in our calculators are negative. So, let me give you a fun fact. Negative and negative is always resulting to positive. This is the rule of signs. Most commonly, calculators separate equation which could be at least negative 1. So when a negative number to another negative number, this must result into positive. Anyway, back to getting the squares, we have negative 8.14 squared, which is equal to 66.2596. And for the square root of negative 7.14, we have 50.9796. The square root of negative 4.14 is equal to 17.1396, while the square root of negative 2.14 is 4.5796. The square root of negative 1.14 is 1.2996. The square root of 1.86 is 97.2196. And lastly, the square root of 16.86 is 284.2596. So now, we need to get the total of all of this. So, to add all of the squared, the total will be 521.7372. The variance of this is 74.53. We divide our answer to 7, which makes our answer 74.5338. And for the standard deviation, we have 8.633. To get this, we must get the square root of 71.5338. Lastly, for our range, we need to subtract with the highest value to the lowest value. Our highest value is 22 and our lowest is 1. Subtract 1 from 22 and our answer is 21. This is now the answer for the range. Now that we completed that, let us answer the second. So, hello everyone, we are at our second problem, which is to find the standard deviation, variance, and the range. for now we have 3, 4, 7, 11, 12, 12, 15, and 16. So the first thing to do is add all of them, and the answer will be 78. Next, we will divide by the number of samples. So if we have 78, we're going to divide it by 8 because as you can see, 1, 2, 3, 4, 5, 6, 7, 8. So you're going to divide 78 by 8 and the answer will be 9.75. So next, we're going to use 9.75 so that we can subtract these numbers from it. So 4 minus 9.75, 7 minus 9.75, and so on. So these are the answers. So when we go back here, we have 4 minus 9.75. The answer that is shown is 6.75 and so on. So after that, we get their squared. So negative 6.75, which is the answer from 4 minus 9.75 is negative 6.75, and the square root of that is 45.5625. So now we have our standard deviation, variance, and the range. So for our standard deviation, we have 4.53,458. For the variance, we have 20.56 and 25. For the range, we have 13. So if you are still confused by now, it's okay. We still have one more example so that we can further understand it even more. So for our third problem, the given samples are 2.1, 3.0, 1.9, 1.5, and 4.8. So this isn't that hard, but it is different and it is unusual since this is decimals and not a whole number. So again, the first thing we need to do is to add them all. So 2.1 plus 3.0 plus 1.9 plus 1.5 plus 4.8 rather. So our answer from that is 13.3. So since 13.3 is our answer, we're going to divide it into the number of samples, which is 5. So if you count the samples again, we have 1, 2, 3, 4, 5. So 13.3 divided by the number of samples, which is 5. So 13.3 divided by 5 is equal to 2.66. So again, we have to subtract and get the squared. So 2.1 minus 2.66, 3.0 minus 2.66, and so on. So the answer to that, to 2.1 minus 2.66 is negative 0.56. And as you can see, those are the answers from what we got. So here is another reminder that since the numbers are negative and we're going to multiply it, we'll put it into squares rather. Always remember that even if it is negative, it will always be positive, and even if you try to use the calculator for it and it says that it's negative, it's actually positive. So negative 0.56 squared is equal to 0.3136. 0.34 squared is equal to 0.1156, and so on. So lastly, we have our answers, and there are some short explanation down there so that you can fully understand. So there you have it, credit sources and things to remember. So for this, I will just talk over and please listen to what I'm saying. So for the reference, I have used my math professor's videos for reference. You can check out his YouTube channel. It's called Wow Math. And for fun fact, there you have it, which is you when you're gonna get a squared, make sure that even if it is negative, it will always come out as positive.